All right, so the first couple of problems here, we want to know the final price of something after the price is changing by some percentage. In the first one, we have a markup. When might we see a markup happen? When would we see something like a 50% markup? So if you think about what's going on here, let's say the store buys the video game for $20. They can't sell it for $20 because then they don't make any money. And they have bills to pay, and they have to pay their workers and stuff. So they're going to go out of business if they don't mark up the prices. So they're going to mark up the price of this video game so that they make some money on it. All right, so the store buys it for $20, but they need to mark it up so they make some money. So how do we figure out what that markup is going to be? What are we going to do? Start at 100%. And then what? Add 50. The price is going up by 50%. That's going to give us what? 150%. Don't forget, when you have percents, make sure you put the percent symbol on there. And then that percent, we don't really want to work with percents. We want to work with decimals. So we're going to change that to a decimal. 150% is 150 out of 100. So we get 1.5. So 150 divided by 100 gives us 1.5. This right here is the multiplier that's going to tell us how much the video game is actually going to sell for. If we wanted to figure that out, we could just take 20 times 1.5, and that would turn out to be $30. So the store is actually going to sell the video game for $30. At least they're going to try to. But if it doesn't sell, they might put it on sale. So they mark it off, they put it on clearance for 50% off. So how are we going to figure out what happens then? Start at 100% and do what? We're going to subtract 50%. And when we subtract 50% from 100%, we get 50%. We change that to a decimal and we get 0.5. Now, before we do anything else, you might think that since the price went up by 50% and then down by 50%, we'd probably get back to where we started, right? Wouldn't that make sense? Yeah, it actually doesn't work out that way, though, does it? So if it goes up by 50% and then down by 50%, it's actually going to be different from where it started. And we're going to see here in a second exactly what that's going to be. So how do we figure out the final price of the video game after the markup and after the discount? Okay, so we take the $20 and we multiply it by those multipliers. So we take 20 times 1.5. And if I stop there, that's going to tell us how much it is with the markup. Again, that's going to be 30, but we can keep going here. We can do this all in one step. Multiply again by 0.5. And that gives us what? $15. Now, make sure you put the dollar sign on there. In fact, make sure you put the dollar sign here and here because this 20 is $20. So make sure that you keep your units straight there. You could also write this $15 like what? 15.00, including dollars and cents. You don't have to have the 0.00 here in this one because it's exactly $15. Now, what's the problem with what the store did, just from their perspective? If they're trying to sell something to get rid of it, how much did they pay for the video game to start with? $20. How much did they end up selling it for? $15. So what's the problem with that? They lost $5, right? So if you were doing something like this, you'd have to be careful. If you mark it up the same as you discount it, it's actually not the same if you're talking about percentages. So you're going to lose out when you do something like that if you're the store. It's kind of nice for the person buying the video game, though, right? Yeah. All right, next one, we have a sweater that's normally priced at $34.99. This is what the store is selling the sweater for, so we don't have to worry about marking it up. It's on sale for 33% off, but we're also going to have to pay tax. So kind of like that first one, we're going to have to do two different multipliers, right? So somebody help me out with the first one. Okay, so we're going to start at 100%, and we're going to take away or subtract 33%. That's going to be a discount, and we end up with what, Taylor? 67%. And then we need to change that percent to a, which would be what? 0.67. We divide by 100 or move the decimal place 2 times to the left. All right, so if we multiply any dollar amount by 0.67, that's going to tell us how much it's going to be after a 33% discount. But let's go ahead and add the tax in all at the same time. So we need another multiplier for that. How are we going to get that one? Start at 100% again and add 7.75%. That gives us 107.75%. And then we change that to a decimal, move the decimal 2 places to the left, and we get
1.06.
kind of a long number. Do I need to round this to the hundredths place? No, please don't do that. All right, we do not round this here. This is not dollars, it's just a multiplier. And if we round it, then our amount at the end is going to be wrong. So we need to make sure we keep all of those decimals right now in our multiplier. All right, so to find the final price of that sweater, after the discount, but including tax, what are we going to do? We're going to multiply $34.99 times 0.67 times 1.0775, and I'm guessing this is going to give us a big long decimal. Yeah?
Yes.
All right, what do we get? $260,155. Okay. What kind of number is this? Is this a percent that we got here? Is that 25.2 and so on percent? It's 25 what? Dollars. Okay, so we're dealing with money right now. And since we're dealing with money, what do I need to do?
Cross up the last 4 numbers.
Well, yeah, we need to get rid of the last 4 numbers because we want dollars and cents, and that cents is going to be 2 decimal places. So we're going to cross everything off after that. And when we do that, this 6 here could change or it could stay the same. How are we going to decide?
That's the number going forward.
We look at the number after it. That 0, the first number we crossed off, is going to tell us that the 6 is going to
Stay the same.
stay the same. So our final price for this sweater is going to be $25.26. The other couple of problems are just some conversions. We have 5%. We want to change that to a decimal, or I'm sorry, to a fraction. What does percent mean? Out of 100. So 5% means 5 out of 100. And how would I write 5 out of 100 as a fraction? 5 over 100. So 5 out of 100 is the same thing as 5 over 100. So always remember that percent means out of 100, so when we change it to a fraction, we're going to get 100 in the bottom. What can I do with this fraction, though? Can I reduce by 2?
No.
Can I reduce by 5?
Yes.
Yes. Those are the only 2 we have to check, right? We reduce by 5. 5 divided by 5 is 1. That's nice because I know I'm going to be done after this step, right? Because we can never reduce a 1. 100 divided by 5 is
20.
20. So if you were to get a 1 out of 20 on a quiz, that'd be a 5%. Don't do that. 5/7, we want to change that to a percent. Also, we're going to get a big long decimal for this. Actually, 5/7 is a decimal that just keeps going forever. We're going to want to round this to the nearest hundredth of a percent when we get to it. But let's write down our work, show how we're going to get this percent first. How do I change a fraction to a percent? Carl? 5 divided by 7. That'll change the fraction into a decimal. So how do I make it a percent then?
Multiply by 100%.
We'll multiply it by 100%. Good. All right, so we punch that into the calculator, and we get 71.2857. Is that it? Okay. This is going to repeat. You guys remember what a repeating decimal is? Something that repeats the same pattern over and over again. So it actually keeps going after this. It doesn't really matter that it does, but it's going to keep going like this, 1428557, 1428557, 14, and so on and forever. We're not going to write those numbers forever, though, are we? No. We want to round it to the nearest hundredth of a percent. Remember, this number right here that we have, I'm going to get rid of these last few that I wrote. This is a percent. So we want to round it to the nearest hundredth of this percent. Where's the hundredths place? What number is in the hundredths place?
2.
The 2. We're going to round that to everything else we cross off. And how do we decide if that 2 stays or changes?
Number 4.
We look at the 8 next to it. So we look at the number to the right. That first number I crossed off is 5 or more. So what happens to the 2?
Goes up.
It goes up. So our final percent with rounding is going to be 71.433. percent.